Hi, welcome to this demo about data deduplication. So in this lesson, we will see three different, I would say, deduplication implementations, starting by one which is natively provided by Apache Spark with the drop duplicate method. But before all other things, I will start the Docker containers. And as you can, here, as you can see here, we have this time of course, Apache Kafka, but also ScyllaDB, which is a key-based NoSQL data store, columnar family-based to be more precise, but it's accessed only by key. And the idea of using ScyllaDB will be useful in the second demo, so I will just skip this part for now, and I will explain to you the duplication method using Apache Spark drop duplicates. So here we have our reading part, which is quite straightforward, with all the parts required to parse our JSON and extract two columns that we are going to use for the deduplication: visit, time, and event ID. So these columns are produced here in the data generator as a part of the JSON input. And here there are multiple configurations or multiple components that are important. So first, our drop duplicates method, where we are using event ID and visit time, and second, the watermark. So watermark is the concept that I will cover more in details in the module number 6. But here, for the matter of this lesson, you should know that the watermark is used in this particular context to keep the buffering, to I would say control the buffering time. So how does it work under the hood? Under the hood, Apache Spark will receive all the records and store the keys for these records in the state store. And the state store will be, of course, checkpointed for the fault tolerance, but it will not grow indefinitely. In fact, after 10 minutes, Spark will remove the records, so the keys, older than 10 minutes, so that it somehow controls how how long we can deduplicate the event, because if you receive the same event after 10 minutes, well, of course, we will insert it because it will not be present anymore in this buffer. So that's the first key element. Remember, it also relies to something I have said before in the theory lesson, that the buffering is always a kind of best effort or not perfect deduplication solution, because of course, to avoid too heavy resources, or to avoid to have too much resources, we delimit this deduplication time in a kind of window, and here the window is of 10 minutes. So that was the first part, and the second part is this schema. So you may be a bit surprised because the schema has only two columns, and we in our input we generate three. So why two columns? Simply because these are the columns I'm using to the duplication. I'm not using them to write data to our deduped events topic. I simply take the value column here. So I'm taking the value column here by selecting it explicitly and removing two drop duplicates columns just before writing data to the topic. So let me run data generator first, and after a few records, I will start the duplication key-based sync. Okay, I have already few records, and I will start my drop duplicate. Okay, the job is running. And now I will start a consumer on top for this deduped events topic and see visually if I can spot any duplicates. But as you can see, there is no duplicates at all. So we always have a new unique pair of event time and visit, event ID and visit time. So that was for the first demo, and let me now stop the code and stop data generator. And before launching the deduplication demo, I will need to do some setup. And generally, this setup simply prepares the execution context for my ScyllaDB. So I'm creating the key space and table where I'm using event ID and visit ID as the unique keys. And what about the job itself? It's quite similar to the previous one, except that I'm explicitly defining the visit time column, and I'm using a different sync. So the sync is a for each writer where there is the open method that is called only once per task, and that must return true if the partition should be processed. In my case, it's my case. And in this open method, I'm initializing the connection to ScyllaDB cluster, and later the whole processing logic happens inside this process. Well, typically it's more in the flash buffer because process simply verifies whether we accumulated enough records to flash them to CynaDB or not. Even if it's not the case, we add the row to the buffer. Otherwise, we call this flash buffer function that uses bulk operation. So in CyllaDB is a batch operation to insert multiple rows at once. So you certainly remember the lesson about data enrichment where I used a bulk API of Elasticsearch to read the data. Here I'm doing exactly the same, but for the writing. So still with the same purpose, with the same goal to reduce the number of network calls, and of course, if you as I will repeat maybe myself, but if you multiple the cost of a single request by the number of rows you have to process, well, you will have a quite huge number. And here, since we are grouping, we will reduce this number we will reduce it by the number of items in the batch. So we are generating our insert and that's all. And to demonstrate that, I will again start data generator. I will start my deduplication job. Okay, it's running. So now I will stop the data generator so that I can keep the same number of records for the second run of the same job on top of the same data. And you will see that I should retrieve the same number of rows written to ScyllaDB. So we can already see that we are not processing any microbatch. So I stopped the command. So I stopped the job. I connected to ScyllaDB. And now I will count the number of visits. So we have 170 visits. Now I will delete the checkpoint. So checkpoint is the place where Spark stores the data processed so far. So generally, by removing the checkpoint, I will tell to Spark, hey Spark, reprocess everything with this configuration. So if we process everything from the beginning with 10 records per micro batch. So let me start the code. And yes, the writer is currently running. We have 16 micro batches as previously. And the number of rows didn't change. So here in this strategy, we rely on the data sync idempotency. Remember, Apache Spark is at least once processing framework, meaning that in case of a failure, for example, if you have a microbatch failure and you restart it, Apache Spark may reprocess some of already successfully processed tasks in the previous execution, meaning that obviously you will deliver data twice for these tasks. And when you use an idempotent data sync like ScyllaDB in my case, you can reply the microbatch as many times as you want. And thanks to this key-based approach, key-based storage, you will always find a single row for each input, for each processed row. There is an important thing to remember though, is to keep the keys idempotent, meaning that if you replay the task, it should generate the same keys for the same rows. So that was for the second scenario. And now I will use transactions. So Kafka is one of databases it's technically not a pure database, but let's take the shortcut and call it a database. It's a database data store, typically a better name maybe, that supports transactions. So in this demo, I will run the producer and consumer. The producer will be a transactional producer that will start a new transaction and try to generate 50 records. However, after processing 20 records, there will be a failure and the transaction will be aborted. Hopefully for the producer, it can be restarted, and in the second run, it will try to reprocess the same, regenerate the same records, and this time we will commit the transaction. The difference between these two runs is this run ID. So here we have a run ID number 1, here we have the run ID number 2. And the consumer, since it's configured as transactional, so it reads only the committed offset, the consumer should see only this part. You shouldn't see the 20 rows for the first run. Let's see if it's the case. So I will start my consumers. It will of course recreate the topics. I will use different topic here. So we can see that we have here our consumers. We have our error. We have the retry for the transaction. And as you can see, the consumer sees so only the record for the run number 2. And it's another strategy that you can apply to guarantee the exactly once, so to provide unique records to your data consumers. So to sum up, we saw 3 different strategies. The first strategy relying on Apache Spark duplicates method. The second strategy relying on the data store idempotency, and the first strategy relying on the data store transactions. And it's all for this lesson. So remember these 3 methods, use them wisely accordingly to your use case, and remember also the trade-offs. So as for example, the buffer, so the window buffer time size for the drop duplicates. Thanks for watching and see you in the next lesson.